Hello, this is Brett from SurvivalComms. Today we have the BK Technologies BKR9000 Multiband P25 portable radio to look at. And this radio is made right here in Central Florida. This radio is capable of operation on VHF, UHF, and 700 and 800 megahertz. It does analog FM and P25 digital audio, and it works in a conventional and P25 phase 1 and 2 trunking environment. This particular radio is a tier 3.5, which is the full keypad and display as well as a top display. Now this radio, like other competing products in this market, is extremely feature rich, and I've included links to the manufacturer's information in the video description and encourage you to look at that for any specific answers to feature set questions, because in this content here we're just going to be scratching the surface. Today we're going to be going over the physical package of the radio, the control set, and the common accessories. And then we're going to do some performance testing of this radio against a Motorola APX8000, which is a competing product for this particular radio. And then we're going to do a subjective audio quality test on P25 and analog audio. This is going to be a lot of fun. Let's get started. So let's look at the radios side by side with one another, and it's easy to see that the BKR9000 is larger in physical package size than the APX8000 as shown here. The radio, the BKR9000, weighs 23.5 ounces, and the Motorola APX8000 as shown here weighs 19 ounces. The BKR9000 is 7.5 inches tall from the top of the channel selector to the bottom, and is 3 1/8 inches by 2 1/8 inches across the top, and 2 5/16 inches by 1 11/16 inches across the bottom. And as with most of the radios we've looked at recently, the elephant in the room is the size of the antenna. And now, as radio people, we know that the multiband radios are going to require an antenna that will operate effectively at VHF, and this is no different. Here are the antennas for the BKR9000 and the APX8000 side by side. Both antennas use a Motorola-style female SMA connector. The BKR9000 antenna is 2 inches longer than the Apex's, which should make for an interesting comparison. Let's put these on the chassis simulator and gather some data. Here is the VHF performance of the BKR9000 antenna, and we can see the size of the antenna does allow for broad bandwidth, but the best case return loss comes up just short of the 10 dB standard we like to see. Compare the previous results with the Apex antenna, and it's pretty clear that the longer length made a difference in VHF bandwidth, but best case return loss measurement of the Apex antenna at VHF is better by almost 4 dB. The BKR antenna at UHF is broadbanded, favoring the higher end of the range where it demonstrated a return loss of almost 18 dB. The Apex antenna at UHF is broadbanded as well and favors the lower to mid end of the range, demonstrating a best case return loss measurement of 12.4 dB. The BKR antenna at 700 and 800 megahertz easily covers the range, demonstrating a best case return loss of 13 dB. The Apex antenna at 700 and 800 megahertz easily covers the range as well, favoring the 800 band and demonstrating a very impressive best case return loss of 25.66 dB. Now let's talk about the physical package of the radio. Technically this is the front of the radio. Our push to talk's on the left, and on our right is the accessory connector. On the opposite side we have our display. This is our speaker. Our speaker will deliver 3 watts of audio. Here is one of our 2 microphones. The radio is a bottom-loading battery design, and our battery is a 7.2 volt 4900 milliamp hour battery pack, and the spec sheet says this will provide 12 hours of battery life depending on duty cycle and use of options such as GPS, Wi-Fi, or Bluetooth. The battery slides along grooves here in the metal chassis, and these are the locking recesses for the battery here, so it's a very strong assembly. You can see our battery contacts here and our data plate here. The radio has an aluminum monolithic chassis, and the plastic housing panels are secured to this chassis with the use of machine screws on the housing panels as well as on the control deck on top. Overall, the radio has an extremely solid feel to it. Now, one thing I have a gripe about is this rubber overmolding that they've placed on the plastic panels here. Not a big fan of rubber overmolding. My experience with it is that over time it degrades and becomes a sticky mess depending upon the environment of the radio and the age of the rubber overmolding. So time will tell if that becomes a problem with this particular radio. Another gripe I have with the physical package, and it may sound petty, is the excessive use of branding all over the radio. If you even go underneath the accessory cover here and look at our accessory connector, you can still see branding evident here as well. On this side of the radio, we see our display, our second microphone, and we'll go ahead and turn it on, and you'll see how long it takes for it to boot up, and note the time, and the time it takes to boot up is not bad. It's much like any other radio of this genre. The keys are large and easy to manipulate, and they're also backlit. And again, all of this stuff is programmable. If you wanted to operate the radio in a tactical environment, you didn't want all this stuff to light up, it's easy to inhibit such in the programming. The buttons are easy to manipulate, and you can see here that we have our up and down here, our menu. In our menu, you can see that this one here is populated with a lot of options, and of course, you wouldn't want to use all these options. And customer customization in modern public safety radios is absolutely incredible. The wide variety of things you can program the radio to do. I mean, you could totally take this radio and set it up to the bare minimum for an end user, or you could totally geek out and have all the options available to the technician. Now, if you look here, we've got our GPS turned on. This indicates talk around, and this is our battery life indicator. When you have this radio operating in a trunking environment, the control channel will show up. Its RSSI is displayed in decibel milliwatts, which is really cool. The radio also features a very powerful, go back here, keypad programming or front panel programming. Default password is 6 zeros. You can see that you can edit all kinds of features, and it's much different. You know, normally front panel programming is just for zone and channel contents, whereas this here you can actually manipulate a lot of the other features. And again, this is something you don't have to turn on in the radio for the regular end user if you don't want to do that, which I wouldn't recommend it. These are some of the global options here. And then we'll go to our channel contents here. And if we wanted to edit a channel, you select the zone, and then we'll go to this one here, and you can see your channel label, frequency mode, your receive guard or transmit guard. That's basically your selective signaling protocol, PL or DCS. And then you can also select it to be either digital or analog, narrowband or wideband. So again, the FPP options in this particular radio are pretty stout. On the left-hand side of the radio, you can see our metal chassis. You can also see the 3 programmable buttons here, and then our push-to-talk switch, and there is a ridge of plastic surrounding the push-to-talk switch to protect it against inadvertent key presses, and there's also a little bit taller on this end of it here to give you a tactile feel that you're on the push-to-talk switch. And on the right-hand side of the radio, we have our accessory connector, and our anchor points for our accessories are made of metal, which is nice. And now we come to the top of the control deck of the radio. We have a programmable orange button. We have our monochrome display, which just gives us the facts. We have our receive and transmit LED here. We have our volume on-off control. We have a 2-position concentric switch. It's programmable. We have our channel selector knob, and we have a 4-position programmable switch here. And our RF connector, which has a reinforcement around it that's molded into the plastic, and that's a very good idea to keep the antenna from cleaving off. And the knobs are slightly oversized and they are easy to manipulate with gloves. If I had one thing that I would want to add to the top of this, it would probably be some kind of a reinforcement here, similar to what's around the antenna, to protect the potentiometer here on the outside from impact. Because you can see right here, it wouldn't take a whole lot of force to inflict damage to this particular control. And that's something to consider. Whenever you increase the size of the controls, you're increasing the amount of leverage that's on the shaft of the control, and it becomes much easier to damage things when you drop them. Now let's look at some of the common accessories for the BKR9000. The first is a speaker microphone. It's a pretty standard arrangement. Programmable orange button at the top, volume control, paddle control here, push to talk switch, epaulet clip, and an earphone jack at the base of the speaker microphone. The cable is substantial, more substantial than the Motorola product, and time will tell if they use the same incredible self-destructing plastic that Motorola uses on their strain reliefs. And you can see where it interfaces with our universal connector here. You can see that it is metal overmolded here to give it some strength to where it'll interface on the side of the radio, and our thumb screw right here. Next we'll look at the holster for the BKR9000 that's provided with it. You have your belt clip here. It's made of plastic, and again with the branding. Just like the Apex's holster, radio slides into it, except it's a lot more difficult to get this out because you can see these projections in the molding here. You have to place your thumb here against the holster to pull it out. So it makes it a little more secure than the Motorola, as it won't fall out like they will sometimes with the Apex. And again, just use your thumb and you can withdraw it from the holster. Another important accessory, of course, is the battery charger, and this is the battery charger I was provided with the radio, and it will charge a radio and a spare battery pack. It outputs 8.35 volts at 1.35 amps, so you can do the math on how long it'll take to charge. The power supply for it that's provided is a 12 volt power supply supplying 1 amp of current, and it just uses a 5.5 millimeter plug. So if you wanted to use something like this and run it off a battery pack, if you had to do so, you certainly could. And again, you notice that we have the branding, and the branding is bilateral, so again, kind of over the top. Now we are moving on to testing the BKR9000 and comparing the results to the APX8000 on my service monitor. We're going to start with VHF transmit with the BKR, and then move to VHF transmit on the Apex. This will be done followed by UHF and then 800 following the same sequence. All testing is done on 25 kilohertz analog FM, and the only two variables we are looking at in this testing is frequency error and RF power output, as there was no real difference in measured deviation. Mind you that both of these variables are able to be adjusted and aligned by suitably trained and equipped end-user organization technical support staff. The BKR on VHF exhibited a frequency error of plus 80 Hz and delivered 6 watts of power into the load. The Apex on VHF exhibited a frequency error of plus 48 Hz and delivered 6.5 watts of RF into the load. The BKR on UHF exhibited a frequency error of plus 260 Hz and delivered 5.1 watts of RF into the load. The Apex on UHF exhibited a frequency error of plus 160 Hz and delivered 5.7 watts of RF into the load. The BKR on 800 exhibited a frequency error of plus 510 Hz and delivered 2.7 watts of RF into the load. The Apex on 800 exhibited a frequency error of plus 320 Hz and delivered 3.5 watts of RF into the load. Now we are moving into receiver testing on my service monitor, and the device is under test and the bands will flow the same as the transmit testing. The results will be the level of signal that provides a 12 dB SINAD. Our BKR at VHF required minus 123 decibel milliwatts. Our Apex at VHF required minus 123.2 decibel milliwatts. Our BKR at UHF required minus 119.1 decibel milliwatts. Our Apex at UHF required minus 121.2 decibel milliwatts. Our BKR at 800 required minus 119.5 decibel milliwatts, and our Apex at 800 required minus 120 decibel milliwatts. There wasn't a tremendous amount of difference between the two radios, with the exception of frequency error at 800 in the BKR. And this might explain why I personally experienced better fringe area 800 system performance with the Apex over the BKR9000. But again, a simple alignment can address that. This test we are looking at now is just a simple transmit spectral purity test, and spoiler alert, both the BKR9000 and the APX8000 were clean. The only thing we are showing is the BKR9000 at VHF, UHF, and 800. As important as receiver sensitivity is, we also have to consider receiver selectivity. That is the ability of the radio to receiver to reject signals that are outside of its tuned frequency. So we're going to test both of our radios on VHF, which is the most sensitive band in both of our radios under test. And we're going to inject a 100 decibel milliwatt signal at VHF, and then we're going to step away 10 kilohertz at a time and see if the radios still receive this signal. So we start out with our squelches open, and you can hear our Apex. Now we're going to start out with a signal on frequency. Now let's step 10 kilohertz away and see what happens. And that's good. 10 kilohertz away, you cannot hear the interfering signal. Now let's repeat the test with our BKR9000. Open squelch. Sending our signal now. Now let's go ahead and send a signal 10 kilohertz away. And we can just barely hear it. Let's go another 10 kilohertz away. And we can't hear the signal at all. Now, to show you the results you do not want to see in this kind of test, let's do this with a Baofeng. Starting out on our tuned frequency, going 10 kilohertz away, 20 kilohertz away, 30 kilohertz away, 40 kilohertz away, and 50 kilohertz away. Now we're going to perform a relative adjacent channel rejection test. We're going to use two signal generators, the output of which are connected to an isolated RF combiner, and from the combiner they are attached to the input of our device under test. Generator 1 is generating a VHF signal at a level of minus 100 decibel milliwatts modulated with a 1 kilohertz tone on the frequency our receiver is tuned for. Then we will generate a second interfering signal 25 kilohertz away at a level of minus 80 decibel milliwatts modulated with a 500 hertz tone. We shouldn't receive any kind of interference with the primary tuned signal, and if we do, it should be moderate. Let's see how our devices perform. Okay, our receiver is on, squelch is open, primary signal on, now interfering signal on. And you can see it does not interfere with our received signal at all. Very good. Now let's repeat the test with our BKR9000. Squelch is open. Generating first signal down. Now generating interfering signal. And you could just barely hear the slightest hiss in there. Second signal off. Very good. Now for laughs, let's repeat this test with the Baofeng. Primary signal on. Interfering signal on. Interfering signal off. P25 audio quality test.
Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over.
The cost of this radio, completely optioned out, is less than $6,000, and that represents an excellent value for this particular market. In reviewing the data and putting this all together, I personally believe that this radio performed well in testing and stacked up well against the Apex in the limited time that I've had it. The radio itself feels solid and the controls are extremely well laid out. I recently had an opportunity to spend some time with a representative of the company, and he made mention of one of these radios being run over by a piece of fire apparatus and being completely functional after that incident, outside of some scratches to the housing and things of that nature. You know, the real review of any radio used in the public safety arena is the test of time. And that is one reason why you see a considerable amount of brand loyalty in these circles. It goes far beyond end user equipment and more into the established relationships that often have the greatest impact on procurement decisions. And that is why I'm grateful for the opportunity to test equipment such as this and share my observations with the viewer in hopes that it expands their knowledge base of what is available. I hope this helps. This is Brett from SurvivalComms. Till next time.